Earth has always been the first shelter of the human mind. Long before we learned to name the stars, before we measured the distances between worlds, before we understood that the pale river of the Milky Way was made of suns, every human life unfolded beneath one atmosphere, one gravity, one sky. We were born inside a narrow layer of air wrapped around a rocky planet, warmed by a middle-aged star, protected by a magnetic field we could not see, carried through space without feeling the motion. For most of history, this was enough. The world beneath our feet seemed less like a place than the condition of existence itself. Yet the moment humanity discovered the scale of the cosmos, Earth changed. It remained home, but it also became visible as a body among other bodies, a small blue planet orbiting one ordinary star in a galaxy of hundreds of billions. The ancient ground became an object in space. The ocean, the desert, the forest, the city, the human face, the memory of every civilization and every grave, all of it could be placed inside a single photograph taken from far away. That realization did something permanent to us. It made the planet more precious, and it made confinement more difficult to accept. The question now facing humanity is simple in wording and almost impossible in consequence. Do we remain a species of one world, refining our civilization inside the only biosphere we have ever known? Or do we slowly become a civilization of many worlds, carrying life beyond the place where it began? This decision will unfold across centuries, through engineering, politics, economics, ethics, fear, ambition, accidents, and dreams. It may never be voted on in a single room. It may never be announced as one turning point. Still, beneath the noise of the age, this is one of the deepest choices our species will ever make. To understand the weight of the decision, we first have to understand the improbability of the place from which we are making it. Earth is not merely a planet with water. It is a rare arrangement of conditions held together with astonishing precision over geological time. It has liquid oceans spread across its surface, an atmosphere thick enough to breathe and thin enough to let sunlight through, a carbon cycle that regulates temperature across deep time, a large moon that has helped stabilize its axial tilt, plate tectonics that recycle minerals and carbon, and a magnetic field that helps shield the surface from the solar wind. None of these features makes Earth unique in a mystical sense. Together, they make Earth extraordinarily difficult to replace. From space, the planet appears calm. White clouds drift over blue water. Continents rest like weathered islands in an illuminated sea. The image invites tenderness, almost serenity. Yet that serenity is a surface expression of violent balances. The crust moves, the climate shifts, ice ages advance and retreat. Asteroids cross Earth's orbit. Volcanoes alter the atmosphere. Species rise, dominate, and vanish. The long story of life has never been a story of safety. It has been a story of endurance inside changing conditions, with extinction always present as a background possibility. Human civilization has existed for only a brief moment within that story. Agriculture emerged during an unusually stable climatic interval after the last ice age. Cities, writing, law, metallurgy, navigation, medicine, finance, industry, computing, satellites, and global communication all developed inside the calm of the Holocene and its aftermath. We often speak as though civilization were the natural direction of intelligence. In reality, it is a delicate construction supported by rainfall patterns, coastlines, soils, pollinators, ocean chemistry, stable seasons, and the availability of energy. A change in any of these foundations can move through society like a crack through glass. This fragility is easy to forget because modern civilization creates the sensation of control. We live inside electrical grids, supply chains, weather forecasts, hospitals, markets, ports, satellites, and data centers. We see the surface of order and assume depth. Yet our systems remain dependent on planetary conditions they did not create. A severe solar storm could damage satellites and electrical infrastructure. A large asteroid could alter history in an afternoon. A pandemic can move through the world in weeks. Climate disruption can reshape agriculture, migration, insurance, conflict, and political stability. Earth is generous, but it is not a machine built for our convenience. The argument for becoming a spacefaring civilization often begins with escape, but escape is too narrow a word. No human settlement on the Moon or Mars would replace Earth for a very long time, perhaps never in full. The early cities beyond Earth would be harsher than the coldest desert, more enclosed than any submarine, more dependent on technology than any laboratory. Their purpose would not be to abandon the home world. Their purpose would be to create redundancy for life, knowledge, culture, and human continuity. A civilization living only on Earth is vast by human standards and fragile by cosmic standards. A civilization with roots in more than one world would still be vulnerable, but its vulnerability would have a different shape. The dream of leaving Earth is older than rockets. It begins in myth, in stories of gods climbing the sky, heroes crossing celestial realms, and souls traveling among stars. For most of history, the heavens were unreachable by definition. They were the domain of divinity, fate, or perfect geometry. The sky belonged to imagination because no body could enter it. Yet the human mind kept returning to it, century after century, as if altitude itself were a form of prophecy. The scientific revolution changed the sky from a ceiling into a place. The moon became a world with mountains and shadows. The planets became bodies moving by laws rather than wandering lights. Telescopes opened the darkness, and the darkness grew larger every time we looked. The more we learned, the less the universe resembled an ornament surrounding Earth. It became a physical reality, immense and indifferent, filled with matter, radiation, gravity, and time. Once the heavens became places, the question of reaching them became technical rather than sacred. The first rockets did not carry explorers. They carried weapons, instruments, and the anxieties of nations. Spaceflight was born inside the 20th century, a century of genius and catastrophe, where the same industrial power that built antibiotics, radio astronomy, and digital computation also built nuclear arsenals. The ascent into space was therefore marked from the beginning by contradiction. It was a triumph of intelligence shaped by rivalry. It showed what humanity could achieve when urgency, fear, and ambition converged. Then came the first artificial satellite, the first human in orbit, the first footsteps on the moon. Those events did not simply expand technology. They altered the human self-image. For the first time, people crossed the boundary between Earth and space with their bodies. The moon landing remains one of the strangest moments in history because it combined extraordinary distance with intimate human vulnerability. A fragile suit, a boot in dust, a voice traveling across emptiness, a ladder descending from a machine wrapped in foil and mathematics. The scene was almost absurd in its delicacy, and that delicacy made it powerful. After the moon, the dream did not disappear, but it slowed. Low Earth orbit became the main human frontier. Space stations replaced lunar voyages. Robots moved outward with greater courage than people. They flew past Jupiter, landed on Mars, crossed the outer solar system, sampled asteroids, mapped comets, measured the afterglow of the early universe, and stared into the atmospheres of worlds around distant stars. Human bodies remained close to Earth, while human instruments became cosmic. We became a species that could see far more than it could reach. That gap between vision and movement defines the present age. We know enough to understand the scale of possibility, and we are still technically young. We have mapped thousands of exoplanets. We have detected worlds in habitable zones, planets around red dwarfs, hot giants, ocean candidates, super-Earths, mini-Neptunes, and systems unlike anything imagined in older astronomy. NASA has confirmed thousands of planets beyond the solar system, and the number continues to grow as instruments improve. We know the galaxy is rich with worlds, yet the nearest stars remain almost impossibly far. We are standing at the shore, able to describe the ocean, unable to cross it. There's a strong argument for staying on Earth, and it deserves more respect than it often receives. Earth is not a prison. It is the only known living world. Every tree, coral reef, language, animal migration, harvest, child, river, and city belongs to a biosphere that took billions of years to form. To speak of leaving without reverence for Earth is a failure of imagination. Space is beautiful from a distance because we view it through atmosphere, art, and instrumentation. Up close, most of it is lethal emptiness. The surface of Mars is cold, dry, irradiated, and chemically hostile. The Moon has no breathable air, no open water, no soil in the biological sense, no weather, no forests, no sound moving through an atmosphere, no horizon softened by mist. Asteroids are irregular stones moving through darkness. The outer moons may hold oceans beneath ice, but they are locked inside environments where sunlight is faint and distance becomes a form of exile. Even the most promising off-world locations demand sealed habitats, controlled air, recycled water, imported machinery, reliable power, protection from radiation, and constant maintenance. A broken valve in such a place is not an inconvenience. It can become an emergency. The moral concern is equally serious. A civilization that cannot manage Earth wisely may carry its worst habits outward. Extraction, inequality, militarization, territorial rivalry, corporate enclosure, surveillance, and ecological carelessness could follow humanity into space. The language of destiny can become a disguise for appetite. The rhetoric of expansion can make destruction sound noble. If space settlement becomes only a new arena for power, then the future may inherit the oldest failures under a more dramatic sky. There is also the question of money and attention. Every major space project requires resources, expertise, industry, political will, and time. The world already faces poverty, war, climate pressure, biodiversity loss, fragile health systems, and unstable governance. A person can reasonably ask why humanity should build habitats on the Moon when so many homes on Earth remain unsafe, or why we should imagine Mars while coastal cities face rising seas. The objection is not small-minded. It comes from the reality of suffering. A mature argument for space cannot dismiss that objection. It must answer by refusing the fantasy that Earth and space are separate concerns. Weather satellites, climate monitoring, global communication, navigation, disaster response, and planetary science already show that space infrastructure can serve the home world. The same engineering required for closed-loop life support can improve water recycling. The same solar power, battery systems, robotics, remote medicine, and autonomous construction needed beyond Earth can feed innovation on Earth. Space exploration becomes harder to justify when it is framed as escape. It becomes more serious when it is framed as a long extension of planetary stewardship. Staying on Earth in the deepest sense does not mean refusing space. It means recognizing Earth as the center of moral gravity. Any future beyond Earth must begin with the knowledge that our first duty is to the world that made us. The question is whether that duty requires remaining forever within one biosphere, or whether care for life eventually includes carrying it beyond the reach of one planetary catastrophe. The argument for becoming interplanetary begins with time. Human beings think in lifetimes, nations think in election cycles or dynasties, markets think in quarters, and geology thinks in millions of years. The cosmos thinks in billions. Over those scales, no single planet is permanent as a home for intelligence. Earth will not remain as it is. The sun is slowly changing. The climate will evolve. Impacts will occur. Supervolcanoes will erupt. Species will vanish. Continents will drift into new arrangements. Far in the future, the sun will become too bright for Earth's present biosphere. Later still, it will leave the main sequence and transform the inner solar system beyond recognition. The long future does not create an immediate emergency, but it changes the meaning of prudence. A civilization that thinks only in centuries may treat space settlement as optional grandeur. A civilization that thinks in millions of years sees a different picture. If intelligence is rare, if consciousness is fragile, if life capable of understanding the universe has emerged in only a few places, or perhaps only here, then remaining forever on one planet becomes a gamble with everything we are. The wager may last a long time, but the stakes are absolute. There are shorter risks as well. Planetary defense is already a real scientific field, not a fantasy of disaster cinema. NASA and other organizations monitor near-Earth objects because impacts have shaped Earth's history and will continue to occur. The danger from any known large asteroid may be low at a given moment, but the population of objects is large, and uncertainty matters. The DART mission showed that a spacecraft can alter the motion of an asteroid moonlet, proving that impact deflection is physically achievable. That success did not make Earth invulnerable. It showed that foresight can become engineering. Space settlement is not the same thing as planetary defense, but both belong to the same moral category: the refusal to leave the future entirely to chance. A human presence on the Moon, Mars, and eventually in orbital habitats would broaden our industrial base, our scientific reach, and our ability to operate beyond Earth. It would teach us how to live in closed systems, how to build with local materials, how to repair complex machines far from supply chains, how to produce fuel beyond Earth, and how to keep biological life alive under alien conditions. These are survival skills for a technological species. The Moon is likely to be the first testing ground. It is close enough for communication and rescue to remain conceivable, yet alien enough to punish every illusion. Lunar exploration programs now focus on more than flags and footprints. They involve surface operations, scientific instruments, mobility, power systems, habitats, and the long discussion around using local resources such as regolith and possible polar volatiles. The European Space Agency and other institutions have supported research into space resources, including methods for prospecting, extracting, and using materials beyond Earth. The technical goal is practical: reduce dependence on supplies launched from Earth. Mars remains the symbolic prize because it is a world with landscapes, seasons, polar caps, ancient riverbeds, dust storms, and a day close in length to Earth's. It once had liquid water on its surface. It may preserve records of early habitability and perhaps traces of past life if life ever began there. A human settlement on Mars would be extraordinarily difficult, and the first generations would live inside machinery more than landscape. Yet Mars offers something the Moon cannot: a planetary laboratory for learning how a world changes, how atmospheres are lost, how climate history is written in rock, and how human communities behave when Earth becomes a distant star in the sky. To become interplanetary would not make humanity safe in any simple sense. It would make humanity more distributed. That difference matters. A library copied in 2 cities has a better chance of surviving fire. A species living in 2 worlds has a better chance of surviving planetary disaster. A culture capable of building habitats beyond Earth learns to see civilization as something constructed, maintained, and chosen. Space does not forgive carelessness. In that sense, the Interplanetary project could become one of the strictest teachers humanity has ever had. The romance of space often begins where the real difficulty begins to disappear. A rocket rises in flame, the camera trembles, the vehicle pierces cloud, and the human mind turns the event into pure ascent. Yet every launch is an act of violence against gravity. Earth holds us with immense strength. To place mass in orbit requires energy, precision, materials, risk, and money. The first barrier to space civilization is not distance to Mars or Proxima Centauri. It is the cost of climbing out of the well beneath our feet. Low Earth orbit is close in kilometers and distant in economics. A commercial airliner crosses continents with routine efficiency. A spacecraft reaches orbit by carrying propellant, structure, engines, avionics, thermal protection, guidance systems, and payload through extreme vibration, acceleration, heating, and pressure. Reusability has changed the economics of launch, and private industry has accelerated the tempo of orbital access. Even so, space remains expensive because errors are punished severely. A small defect can destroy a mission. A minor miscalculation can waste years of work. Beyond orbit, difficulty multiplies. The Moon requires navigation through cislunar space, landing systems, surface power, dust mitigation, thermal control, communications, mobility, and habitats. Lunar dust is abrasive and electrostatically troublesome. The day-night cycle creates long periods of heat and cold except near certain polar regions. Mars adds atmosphere thin enough to complicate landing and thick enough to create dust storms. It adds months of transit, communication delay, radiation exposure, psychological isolation, and the challenge of returning from a deeper gravity well than the Moon. The human body is also adapted to Earth with quiet precision. Bones, muscles, fluids, vision, immunity, sleep, balance, and psychology evolved under one gravity, one day length, one radiation environment, one biosphere. Microgravity weakens bones and muscles unless countered by exercise. Radiation beyond Earth's magnetic shield raises long-term health risks. Isolation alters mood and cognition. Closed habitats magnify conflict because there is no outside in the ordinary sense. The first settlers beyond Earth would need courage, but courage alone would be inadequate. They would need maintenance discipline, medical planning, emotional resilience, social design, and governance structures built for pressure. Food is another frontier. A settlement that depends entirely on shipments from Earth remains an outpost rather than a civilization. Growing food beyond Earth means controlling light, water, nutrients, microbes, waste, pests, pollination, and crop diversity inside artificial environments. It means turning biology into infrastructure without stripping it of complexity. A wheat field on Earth is already a collaboration among soil, climate, organisms, and human work. A greenhouse on Mars would have to recreate enough of that collaboration inside walls. Energy determines the scale of everything. Solar power is abundant in space, but availability varies by location, dust, night cycles, and distance from the sun. Nuclear power may be essential for reliable baseload energy on the Moon, Mars, and outer destinations. Energy is water extraction, oxygen production, heating, communications, construction, computing, medicine, and transportation. A settlement with insufficient energy becomes a survival capsule. A settlement with abundant energy can begin to behave like a society. The cost of the sky is therefore not merely financial. It is biological, psychological, industrial, political, and moral. Space asks whether humanity can sustain attention across generations. It asks whether we can build systems that do not collapse when spectacle fades. It asks whether ambition can mature into reliability. The first permanent steps beyond Earth will likely be slow, technical, and repetitive. They will involve repairs, failures, budgets, delays, committees, tests, leaks, broken seals, dust-covered panels, and lessons written in caution. That is what civilization looks like before it becomes legend. If humanity leaves Earth in a permanent way, we will not travel alone. We will carry bacteria, seeds, animals, engineered organisms, human embryos perhaps one day, digital archives, languages, rituals, pathogens, myths, and habits. A spacecraft is never only a machine, it is a vessel of biology and culture. The decision to settle other worlds is therefore an ethical decision about what kind of life we carry, what we protect, what we alter, and what we may destroy without understanding. Mars is central to this question because of its scientific promise. If life ever existed there, it may have been microbial, ancient, and fragile. It may remain hidden underground, preserved in brines, ice, or rock. Human arrival risks contamination. Earth organisms could confuse the search for Martian life or damage ecosystems we have not yet discovered. Even a dead Mars has scientific value beyond measure, because its geology records the history of a planet that began with conditions more Earth-like than today, and then changed dramatically. To rush into settlement without careful exploration would be a form of blindness. Planetary protection is often discussed as a technical protocol, but beneath it lies humility. We do not yet know how common life is. We do not know whether life begins easily wherever chemistry permits, or whether Earth represents an extraordinary accident. We do not know whether Mars, Europa, Enceladus, Titan, or ancient Venus hold clues to independent origins. Until we know more, the first ethical rule is restraint. A living world, even microbial, would be one of the greatest discoveries in history. It should not be trampled by impatience. Terraforming raises even larger questions. The idea of transforming Mars into a more Earth-like world has great imaginative power. Thicker air, warmer temperatures, liquid water, perhaps open landscapes beneath a blue sky. Yet the technical barriers are enormous, and the ethical barriers may be larger. Does humanity have the right to remake an entire planet? Would a lifeless planet have moral standing through its scientific value, beauty, and natural history? Would an inhabited microbial Mars possess a claim against transformation? These questions cannot be solved by engineering alone. There is also the ethics of human communities beyond Earth. The first off-world settlers may be scientists, engineers, technicians, pilots, doctors, and specialists. Later, if settlements grow, children may be born beyond Earth. That possibility changes everything. A child born in a lunar habitat or Martian settlement cannot be treated as an experiment chosen by adults. Their gravity, health, education, legal status, citizenship, bodily autonomy, and right to return become matters of justice. Space settlement cannot be considered mature until it can answer for the lives of people who did not choose the frontier. Governance will matter as much as propulsion. Who owns extracted resources? Who controls air, water, and power in a sealed habitat? What happens when a settlement disagrees with Earth-based authority? Can labor rights exist where leaving a workplace may be physically impossible? Can democracy survive where emergency management requires strict discipline? Can privacy exist in a habitat where every system is monitored for survival? The old political questions will return under sharper conditions. The ethics of carrying life beyond Earth should not paralyze the project, but it should deepen it. Expansion without ethics becomes appetite. Preservation without courage becomes stagnation. A wiser path would treat space as a realm where humanity must become more careful because the consequences are larger and the margins smaller. To carry life into the cosmos is to accept responsibility for more than survival. It is to decide what deserves continuity. A true spacefaring civilization would not be defined only by rockets. Rockets are the beginning, the loudest and most visible part of the system. The deeper transformation would occur when humanity learns to build durable environments beyond Earth. A settlement is not a rocket that stopped moving. It is a living arrangement of air, water, heat, food, waste, repair, law, memory, and meaning. To build one beyond Earth is to learn the architecture of survival from the inside. Closed-loop systems would become central. On Earth, civilization is open to planetary abundance. Waste can be diluted, water can be drawn from rivers and aquifers, air can be renewed by forests and oceans, heat can escape into the atmosphere, and food can grow under the sky. In a habitat beyond Earth, every flow becomes visible. Carbon dioxide must be removed. Oxygen must be produced or stored. Water must be recovered from breath, urine, washing, soil, and machines. Waste must be transformed into input. A leak is a moral event because it reveals the cost of every molecule. This kind of life could change human consciousness. A society that lives inside sealed habitats may develop a more intimate understanding of ecology than one surrounded by invisible abundance. People may learn to see air as infrastructure, water as inheritance, soil as technology, and energy as the quiet foundation of culture. The irony is powerful. Leaving Earth may teach humanity to understand Earth more deeply. A forest is a life support system of staggering sophistication. An ocean is a climate engine. A cloud is part of a planetary machine that no engineer can yet reproduce at full scale. Orbital habitats may eventually become as important as planetary surfaces. Planets attract the imagination because they resemble home, but free space settlements could offer advantages. They can be positioned for sunlight, built with rotation to simulate gravity, expanded modularly, and located near resources or transport routes. Asteroids contain metals, volatiles, and other materials that could support construction without lifting everything from Earth. In the far future, much of human civilization beyond Earth may live inside constructed worlds rather than on natural surfaces. Such habitats are far beyond current capability at large scale, but they are not magic. They are extensions of known principles: pressure vessels, radiation shielding, rotating structures, agriculture, power systems, robotics, mining, manufacturing, medicine, and governance. The challenge is integration. A city is more than the sum of technologies. It is a place where people trust that tomorrow will arrive with air in the walls, water in the pipes, food in storage, law in effect, and someone trained to repair what breaks. The cultural dimension may be even more difficult. Human beings do not live by oxygen alone. They need beauty, ritual, privacy, grief, celebration, boredom, art, humor, conflict, reconciliation, and memory. A purely functional habitat would become a psychological desert. The first architecture beyond Earth must therefore think beyond survival. It must make room for gardens, music, ceremony, education, and the useless forms of beauty that prove a place has become human. To build worlds is not to imitate Earth poorly. It is to construct new forms of habitation while carrying the lessons of Earth with care. The first generation may live under metal and regolith. Later generations may inherit valleys under glass, rotating gardens, libraries in orbit, observatories on the far side of the moon, and towns beneath Martian cliffs. If this future arrives, it will arrive through maintenance before wonder, through plumbing before poetry, through discipline before myth. Then, one day, children may look through a window at Earth and understand it as both origin and distant light. Even if humanity becomes interplanetary, the stars will remain almost impossibly far. The solar system is large enough to humble any civilization. The distance from Earth to Mars changes constantly and can stretch across hundreds of millions of kilometers. The outer planets occupy a realm where sunlight weakens and travel times lengthen into years. Yet even Neptune is nearby compared with the nearest star. Proxima Centauri lies more than 4 light-years away, a distance so large that ordinary language begins to fail. A light-year is often spoken casually, but it is a measure of almost violent scale. Light circles Earth more than 7 times in 1 second. It crosses the distance from the Moon to Earth in a little over 1 second. It takes about 8 minutes to travel from the Sun to Earth. To reach Proxima Centauri, light itself needs more than 4 years. Our fastest spacecraft would require many thousands of years to cross that distance by ordinary trajectories. Interstellar travel is therefore not the next step after Mars in any simple sequence. It is a different category of civilization. Still, the discovery of exoplanets has changed the emotional meaning of the stars. They are no longer abstract suns. Many are centers of planetary systems. Some host worlds in regions where liquid water could exist on the surface under the right conditions. The habitable zone is only a first filter, not a promise of life. Yet it gives astronomy a biological tension. Every small world in the right orbit becomes a question. Every atmosphere measured by future telescopes may carry a clue. The search for life beyond Earth has moved from philosophy into observation. The Habitable Worlds Observatory concept reflects that shift in ambition. Future telescopes are being imagined not merely to count planets, but to characterize potentially habitable ones and search for signs that may indicate life. Such instruments would not carry people to other stars. They would bring other worlds into the realm of evidence. Before humanity ever sends a probe across interstellar space, it may know that a distant atmosphere contains oxygen, methane, water vapor, or other chemical patterns that demand explanation. A point of light could become a biological mystery. The first interstellar missions, if they happen, may be tiny. Concepts involving light sails imagine gram-scale probes accelerated by powerful lasers to a fraction of the speed of light. Such craft would be fragile, brief, and limited, crossing interstellar distance as instruments rather than ships. They might fly through a nearby star system in hours after decades of travel, sending back faint data across the void. Even that would be one of the greatest achievements in history. The first human-made object designed to visit another star within a human timescale. Human interstellar travel is more remote. It would require breakthroughs in propulsion, energy storage, radiation shielding, closed ecosystems, artificial gravity or biological adaptation, and social continuity. A ship traveling for centuries would be less like a vehicle than a moving world. Its passengers might live and die between stars, preserving a mission chosen by ancestors. Such a project would test every idea humanity has about identity, consent, duty, and hope. The stars invite imagination, but they also demand intellectual honesty. They are not close simply because we can see them. The long horizon matters because it changes the shape of the interplanetary decision. The Moon and Mars are not final destinations. They are schools. They teach the species how to live beyond Earth, how to use local resources, how to endure isolation, how to construct habitats, how to govern small, vulnerable communities, how to think in decades and centuries. If humanity ever reaches the stars, the first lessons will have been learned near home, in the dust of the Moon, under the thin sky of Mars, inside orbital workshops, and in the quiet discipline of keeping life alive where it should not easily persist. A strange fear accompanies the spacefaring future, the fear that leaving Earth might make humanity smaller rather than larger. The universe is immense, and every expansion reveals more scale. When we crossed oceans, Earth became known. When we reached orbit, Earth became small. When we mapped the planets, the solar system became a neighborhood of hostile distances. When we discovered exoplanets, the galaxy became a field of inaccessible possibilities. The more we see, the more we understand our limits. This can create despair. A person may look at the distances and conclude that space is a dream built against mathematics. Mars is hard enough. The stars are unreachable for any civilization like ours. The cosmic timescales are too vast. The universe expands, galaxies recede, stars die, entropy deepens, and human ambition seems almost comic beside it. What is a settlement on Mars against a galaxy? What is a lunar base against the age of the cosmos? What is one species against the dark? Yet scale does not erase meaning. A human life is brief, and still it contains love, memory, work, fear, beauty, and choice. A city is small compared with a continent, and still it can hold centuries of culture. A book is small compared with a library, and still it can change a mind. The fact that the universe is vast does not make human action pointless. It makes precision more necessary. We cannot master the cosmos in any imperial sense. We can participate in it with intelligence. Space may also cure certain illusions of dominance. Earth, seen from afar, does not look like a possession. It looks like a shared exposure. Borders vanish. Atmosphere becomes visibly thin. The night side glows with cities, showing both achievement and dependence. Astronauts have often described a shift in perception after seeing Earth from orbit, a sense of unity and fragility that ordinary maps conceal. This perspective will not solve politics by itself, but it offers a corrective to the arrogance of separateness. Becoming a spacefaring civilization should not be imagined as humanity conquering space. Conquest is the wrong metaphor for vacuum, radiation, gravity, and time. A better image is apprenticeship. We would be apprentices to orbital mechanics, closed ecology, materials science, radiation biology, planetary geology, and the severe patience of distance. We would learn through failure because space will not adjust itself to our narratives. The fear of becoming smaller may therefore become a form of wisdom. We are small, and the knowledge is useful. It can make our ambition cleaner, our ethics sharper, and our gratitude deeper. A species that understands its smallness may avoid confusing expansion with entitlement. It may learn that the point of reaching other worlds is not to inflate human importance, but to preserve and deepen the rare capacity to know, care, build, and remember. Every civilization lives with the temptation of postponement. The future appears spacious from a distance. Problems can be deferred because tomorrow seems available. Space settlement, especially, invites delay. The technologies are difficult, the costs are high, the politics are unstable, and the benefits may seem abstract compared with immediate needs. It is easy to imagine that later generations will be richer, wiser, and better equipped. Perhaps they will be. Perhaps they will also inherit fewer options. Technological capacity is not guaranteed to increase forever. Civilizations can stagnate, fragment, collapse, or redirect their energy inward. Knowledge can survive in books while industrial systems decay. Skills can be lost when institutions fail. Supply chains can break. Political will can evaporate. A species that reaches the threshold of spaceflight may not remain there indefinitely. The ability to build rockets, maintain satellites, operate deep space networks, and support complex science depends on a large, educated, cooperative, energy-rich civilization. That condition is historically unusual. There is a window quality to the present age. Humanity has global industry, advanced computation, precision manufacturing, materials science, biotechnology, orbital infrastructure, and a growing private space sector. It also has environmental stress, geopolitical rivalry, misinformation, nuclear risk, and fragile institutions. The same century that may open the solar system may also determine whether Earth remains stable enough to support the effort. The decision is therefore not between Earth and space. The decision is whether civilization can become competent enough to sustain both planetary repair and outward growth. Waiting too long also has a cultural cost. Great projects train societies. They create institutions, skills, expectations, and myths of capability. A civilization that attempts difficult things learns to think differently about time. The building of cathedrals, observatories, universities, canals, vaccines, electrical grids, and space telescopes all required forms of trust extending beyond immediate gratification. Space settlement at its best could become a discipline of long responsibility. It would force people to plan for those they will never meet. The danger is that humanity may become trapped in short horizons. Entertainment, markets, crises, and political cycles can compress attention until only the immediate feels real. A species that cannot think beyond the next crisis will struggle to build futures measured in centuries. Space demands a slower mind. It asks for infrastructure whose value may mature after its builders are gone. It asks for research that may fail before it succeeds. It asks for investment in descendants rather than applause. Still, urgency must be handled carefully. The language of urgency can excuse recklessness. The fact that waiting carries risks does not mean every project should be rushed. The first permanent settlements beyond Earth must be built with caution, transparency, and scientific seriousness. The task is to begin early enough to learn, and slowly enough to learn well. A civilization that moves too late may lose the chance. A civilization that moves carelessly may carry disaster outward. The present may be remembered, if anyone remembers it from far enough in the future, as the age when humanity first understood the decision. We have seen Earth from space. We have touched the moon. We have driven machines across Mars. We have found planets around other stars. We have altered our own climate. We have built tools that can watch asteroids and telescopes that can read ancient light. We have enough knowledge to know that staying forever on one planet is a choice, and enough vulnerability to know that every choice has a cost. The first true step toward a spacefaring civilization may not be the first footprint on Mars or the first child born on the moon. It may be the moment when humanity stops treating space as spectacle and begins treating it as infrastructure. Spectacle burns bright and fades. Infrastructure persists. It is maintained, inspected, repaired, funded, standardized, regulated, and improved. It becomes part of the background on which other achievements depend. Satellites already form the hidden nervous system of modern life. Navigation, timing, finance, communications, weather forecasting, disaster monitoring, military operations, agriculture, and climate science all depend in part on assets above Earth. Most people rarely think about them. That invisibility is a sign of integration. Space has already entered civilization, quietly and deeply. The next step is to extend that integration outward from observation and communication toward industry, science, and habitation. A lunar presence could begin as a research program and become an industrial laboratory. The far side of the moon offers extraordinary potential for radio astronomy, shielded from much of Earth's radio noise. Polar regions may offer access to water ice in permanently shadowed areas, though extraction remains technically complex. Regolith can provide shielding against radiation and micrometeorites. The Moon can teach landing precision, surface construction, autonomous operations, and the politics of shared space before humanity attempts more distant settlements. Mars would teach different lessons. It would test long-duration transit, surface autonomy, in-situ resource use, planetary science, and the psychology of distance. A Mars crew cannot depend on immediate rescue. Communication delays mean that decisions must be local. The planet itself would become both laboratory and adversary. Dust in machines, cold in structures, radiation in tissue, perchlorates in soil, thin air around every habitat. Success there would require a culture of preparation unlike anything in ordinary exploration. Orbital manufacturing may become the quiet bridge between near-Earth space and deeper settlement. In microgravity, certain materials, crystals, fibers, and biological processes may behave differently. Large structures could be assembled without bearing their own weight. Fuel depots could change mission architecture. Robotic construction could reduce risk before humans arrive. The practical future of space may be less cinematic than popular imagination suggests. Tanks, trusses, radiators, cables, depots, shielded modules, repair yards, greenhouses, and autonomous machines working in silence. The first true step is also educational. Children growing up today may live in a world where the Moon has regular missions, Mars has sample returns or human expeditions, private stations operate in orbit, asteroid surveys improve, and telescopes study the atmospheres of Earth-sized planets. Their sense of the possible will differ from that of generations who watched Apollo as a singular miracle. A frontier becomes real when it survives beyond astonishment. For this reason, the decision is not only made by astronauts, engineers, and governments. It is made by teachers, voters, scientists, artists, insurers, farmers, energy planners, legal scholars, and citizens deciding what kind of future deserves patience. A spacefaring civilization cannot be built by enthusiasm alone. It requires a culture that values evidence, competence, continuity, and the protection of life. The first true step is a change in seriousness. The more humanity looks outward, the more it must answer inward. What do we owe the Earth? The answer begins with gratitude, but gratitude without action becomes sentiment. We owe the Earth repair where we have damaged it, restraint where we are tempted to consume blindly, protection where systems are fragile, and attention where complexity exceeds our understanding. A civilization that carries life beyond Earth while degrading the only living world it knows would display a dangerous confusion. Earth is not merely a launch pad for human destiny, it is the original archive of life. The genetic memory of billions of years is written in its organisms. The atmosphere contains the work of ancient microbes. The limestone holds former seas. The coal beds, forests, coral reefs, polar ice, deserts, and deep oceans are chapters in a planetary biography far older than civilization. To damage Earth casually is to destroy pages from a book we have only begun to read. Space exploration can sharpen this awareness. Mars shows what happens when a planet loses much of its atmosphere and surface water. Venus shows the horror of a greenhouse atmosphere taken to extremes. The Moon shows what a world looks like without air, oceans, or life. The outer solar system shows cold on a scale almost beyond ordinary feeling. Every world we study becomes a mirror, revealing by contrast the astonishing hospitality of Earth. The solar system is full of beauty, and almost none of it is gentle to human flesh. The obligation to Earth includes climate stability. Human activity has altered the atmosphere measurably, and the consequences will extend across generations. Sea levels, heat extremes, precipitation patterns, ecosystems, agriculture, and migration are not abstract environmental topics. They are the conditions under which civilization remains governable. A species dreaming of Mars while failing to stabilize its own climate would risk making ambition look like avoidance. The stronger path is to treat climate action and space capability as expressions of the same maturity. the ability to understand planetary systems and act responsibly within them. Biodiversity also belongs in this discussion. When species vanish, unique evolutionary histories vanish with them. A future in which humanity spreads through space while Earth's living richness collapses would be a poor victory. The first gardens beyond Earth should not be monuments to a biosphere we neglected. They should be extensions of a world we fought to preserve. The seed bank, the coral nursery, the protected forest, the restored wetland, and the Martian greenhouse belong to one ethical continuum. We owe Earth honesty as well. Some dreams of space are fueled by impatience with human problems. They imagine a clean beginning elsewhere, free from history. No such clean beginning exists. We will carry ourselves wherever we go. The conflicts and virtues of Earth will travel with us in law, memory, language, and habit. The purpose of going outward cannot be to escape responsibility. It must be to enlarge the field in which responsibility operates. If humanity becomes a civilization of many worlds, Earth should remain the center of remembrance. It may become a protected cradle, a living sanctuary, a source of biological renewal, science, culture, and pilgrimage. Future generations born under artificial skies may study Earth with a reverence we can scarcely imagine. They may see oceans as miracles, rain as luxury, birdsong as an inheritance, and open air as the first wealth. In that future, the decision to leave Earth will have meaning only if it deepens the duty to protect it. The future has no voice in the present. It cannot vote, lobby, purchase, protest, or defend itself. Yet almost every major decision we make sends consequences forward. Carbon dioxide remains in the climate system. Nuclear waste outlives governments. Species extinctions cannot be reversed. Scientific knowledge can empower or endanger. Space infrastructure, if built wisely, may serve descendants whose names we will never know. To think about becoming a spacefaring civilization is therefore to think about justice across time. We owe the future options. A society that consumes every resource, destabilizes every system, and leaves no margin has stolen from people who have not yet arrived. Options are a form of inheritance. Clean water, stable institutions, scientific knowledge, protected ecosystems, diversified energy, resilient food systems, and access to space all expand the range of possible futures. The opposite is narrowing. Fewer choices, more emergencies, harsher trade-offs, and greater dependence on luck. Space can become one of those options, but only if developed with patience. A rushed, extractive, militarized space economy could create conflict without resilience. A thoughtful space civilization could provide observation systems to protect Earth, asteroid surveys to reduce impact risk, off-world archives to preserve knowledge, scientific stations to expand understanding, and eventually settlements that carry human culture beyond one planetary surface. The difference lies in governance and purpose. There is a powerful argument that the future value of intelligence is enormous. If life capable of consciousness is rare, then its preservation matters at cosmic scale. Humanity is flawed, violent, inconsistent, and often short-sighted. It is also capable of compassion, mathematics, music, medicine, architecture, grief, tenderness, and curiosity about galaxies it will never touch. To preserve humanity is not to endorse every part of human history. It is to protect the possibility that our better capacities may continue and mature. Future generations may judge us less by what we dreamed than by what we made durable. They may ask whether we built systems that outlasted fashion, whether we preserved knowledge, whether we reduced avoidable risks, whether we cared for the biosphere, whether we used technology as stewardship or vanity, whether we prepared paths we knew we might never walk. The spacefaring decision is one of those paths. Its reward may belong mostly to people beyond our horizon. This is difficult for modern culture because delayed meaning competes poorly with immediate attention. A lunar power system is less emotionally vivid than a viral image. A telescope calibration is less dramatic than a crisis. A radiation shielding study is less glamorous than a launch. Yet civilizations are often saved by unglamorous competence. The future depends on people who build bridges, maintain records, test seals, monitor asteroids, preserve seeds, measure ice, teach children, and keep institutions honest. What we owe the future is neither blind expansion nor fearful stillness. We owe it a widened field of survival and meaning. We owe it a civilization capable of remaining human under new skies. We owe it the chance to look back at Earth without shame and outward without illusion. The most important decision in human history may not arrive as a single declaration. It may unfold through thousands of smaller decisions, whether to fund a telescope, whether to protect a forest, whether to map an asteroid, whether to build a lunar habitat, whether to regulate space resources, whether to reduce emissions, whether to teach science well, whether to preserve archives, whether to cooperate across borders, whether to design settlements for dignity rather than extraction. The great decision hides inside ordinary policy, engineering choices, cultural habits, and moral priorities. Staying on Earth and becoming a spacefaring civilization are often presented as opposing destinies. In truth, the wiser future may require both forms of devotion. Humanity must remain loyal to Earth because Earth is the source of life, memory, and meaning. Humanity may also need to move beyond Earth because life confined to one world remains exposed to the deep uncertainties of time. The task is not to choose between home and horizon as enemies. The task is to learn how a species can honor its birthplace while preparing for a larger existence. The decision is frightening because it reveals our immaturity. We have enough power to alter a planet, but our wisdom has not grown at the same speed. We can land machines on Mars, yet struggle to govern ourselves with patience. We can detect planets around distant stars, yet fail to protect vulnerable communities from predictable disasters. We can imagine settlements in orbit, yet allow short-term thinking to dominate public life. Space does not absolve these contradictions. It exposes them. That exposure may be useful. The requirements of space civilization are the requirements of maturity made physical. Closed systems, long planning, respect for limits, careful use of resources, international law, technical excellence, psychological resilience, ecological understanding, and responsibility to people not yet born. To build beyond Earth, humanity would have to become better at many of the things Earth already demands. The frontier would be less a place of escape than a severe mirror. Perhaps the deepest reason to go is that life has begun to know the universe through us. Matter on Earth has learned to measure starlight, date ancient rocks, read DNA, split atoms, compose symphonies, mourn the dead, and ask whether it is alone. This does not make humanity the center of the cosmos. It makes humanity a rare expression of the cosmos becoming aware of itself in one small place. To let that awareness remain forever dependent on a single planetary surface may be a risk too great for a mature civilization to accept. Yet the deepest reason to stay loyal to Earth is equally strong. Every dream of the stars begins here. Every astronaut carried Earth in blood, bone, language, memory, and breath. Every spacecraft was built from terrestrial minerals by terrestrial hands under terrestrial weather. Every equation was written by a mind shaped by this planet's gravity and light. If humanity one day spreads through the solar system and beyond, it will not leave Earth behind in any spiritual sense. It will carry Earth as origin, reference, wound, teacher, and home. The decision, then, is not a moment of departure. It is a long act of becoming. We are a young technological species standing between cradle and horizon, frightened by our own power, drawn by distance, bound by responsibility. The sky above us is no longer unreachable, and the ground beneath us is no longer guaranteed. Between those two truths lies the path of the next chapters of human history. If we remain only where we began, we may preserve comfort for a while and inherit the ancient risks of a single world. If we move outward without wisdom, we may scatter our failures across new landscapes. The better future asks more of us. It asks that we repair the Earth while learning the Moon. It asks that we study Mars without arrogance. It asks that we build machines worthy of trust, laws worthy of distance, and cultures worthy of survival. It asks that we become careful enough to deserve the worlds we seek. One day, perhaps, a human being will stand under a sky that is not Earth's sky and look toward a bright point where the home world shines. Around them may be a settlement still young, still vulnerable, still dependent on discipline and memory. They may know that their life exists because generations before them made difficult choices without seeing the final result. They may understand that the most important decision in human history was never only about where humans would live. It was about whether intelligence could learn to care across space and time. The answer has not been written. It is being written now, in laboratories, launch sites, classrooms, parliaments, observatories, farms, workshops, and quiet acts of repair. Earth turns beneath us. The moon waits nearby. Mars keeps its cold record. The asteroids move through darkness. The stars hold their distance, and humanity for the first time can understand the scale of the choice before it.